Point a telescope at the constellation Boötes, keep looking past the nearest stars, and eventually you reach a region of space 330 million light-years across where almost nothing exists. No galaxy clusters, no filaments, no walls of light stretching through the dark the way they do everywhere else in the universe. Just emptiness stretching for a distance so vast that light itself needs 330 million years to cross from one side to the other. Astronomers call it the Boötes Void. Unofficially, it has a simpler name, the Great Nothing. It was found in 1981, almost by accident, when a team led by astronomer Robert Kirshner set out to map the distances to galaxies in a patch of sky using redshift surveys, a technique that lets astronomers build three-dimensional maps of the universe by measuring how fast galaxies are moving away from us. They expected the usual mixture, some dense clusters, some filaments, some moderate gaps, the pattern seen almost everywhere else they had looked. Instead, they found a region of space roughly 700 million light-years away that appeared to contain almost nothing at all. To understand how strange that actually is, you need to understand what should be there. Based on the average density of galaxies across the universe, a region of space that size should contain somewhere around 2,000 galaxies. When astronomers finished mapping the void as thoroughly as their instruments allowed, they found roughly 60. That is not a small discrepancy. That is a region of space with about 3% of the galaxies it should have. Now, to be fair to the universe, empty regions are not unusual on their own. Galaxies are not scattered randomly through space. They are arranged in a cosmic web, threads of filaments and clusters woven around enormous gaps called voids. And these voids actually make up around 80% of the entire volume of the observable universe, while containing only about 10% of its mass. Most galaxies live crowded together along the threads of the web. Most of the actual space in the universe is nearly empty. So why does the Boötes Void get singled out as a genuine mystery rather than simply one void among many? Because of its size and because of how confidently the standard model predicts a hard limit on how large a void like this should be able to grow given the age of the universe and the strength of gravity working to pull matter together and fill in the gaps over time. According to that standard model, a void of this scale should not have had enough time to become quite this empty. And for more than 3 decades, researchers have gone back and forth without settling the question. Some proposing the void could still fit within standard theory if certain assumptions are adjusted, others treating it as a genuine outlier that current models cannot comfortably explain. There is also a more grounded voice in this conversation worth hearing, because not every scientist treats the Boötes Void as some deep, unsolved crisis. Some researchers point out that its existence is broadly consistent with how cosmic structure is expected to grow from the small density variations present in the very early universe, and that voids of roughly this kind are, in fact, part of what the standard picture predicts, even if this particular one sits on the extreme end of the range. The more dramatic framing, they argue, tends to skip that part, so the honest picture is somewhere in the middle. Not a crisis for cosmology, not a fully solved footnote either. A genuinely oversized example of something the universe does everywhere, just pushed further than most researchers expected any single region to go. What makes it more than just a curiosity is what it is being used for now. Because the Boötes Void is close enough and clean enough to study in detail, it has become a kind of natural laboratory, a place where scientists can examine how the handful of galaxies inside it formed and evolved almost entirely in isolation, without the crowding and collisions that shape galaxies everywhere else. Voids like this one are also playing a growing role in one of the biggest open puzzles in modern cosmology, the Hubble tension, since the way voids expand and influence their surroundings may be quietly affecting how we measure the expansion of the universe itself. There is something worth sitting with in a discovery like this. A region of space large enough to contain thousands of galaxies and instead holding almost nothing, sitting quietly in the sky since long before humans existed to notice it, waiting decades to even be found, and still, after more than 40 years of study, not fully understood. What do you think? Is the Boötes Void simply an extreme but ordinary feature of the cosmic web, or is it hinting at something our models are still missing? Let me know in the comments. Subscribe, because next time we are covering the Great Attractor, a mysterious region of enormous gravity pulling our entire galaxy toward it, hidden almost completely from view behind the plane of the Milky Way itself.